In this video, we are going to discuss 4 main logical fallacies found in economics. These 4 fallacies are the correlation causation, we have the composition fallacy, we have the post-hoc, and then the zero-sum game fallacy. So let's start off with the correlation causation. Let's first off define what correlation means. Correlation is whenever 2 variables are related to each other, meaning that whenever you find one event happening, you often find the second one. Great example of this is lightning and thunder, rain and thunder. Whenever you see rain, you often see thunder. Whenever you see thunder, you often see rain. The second aspect is causation. Causation means one variable is affecting another. So, if you say like a weather front affects or causes it to start raining, or a weather front will cause it to start lightning and thundering, that is whenever we have a causation, whenever one is causing another. So, where the fallacy comes in is whenever you have 2 correlated items, but they're not causal. So what that means is we have 2 items like rain and lightning that are correlated, but lightning is not causing rain, and then rain is not causing lightning. But there's actually a third event that is causing both of them. So in this case, in this example, the third event would be a weather front moving through, and it's actually causing lightning and rain. Well, lightning and rain are correlated, but they aren't causing each other. So where the fallacy comes in is whenever somebody believes that one of the 2 correlated items is actually causing another. In this case, it would be a fallacy to believe that lightning causes rain or thunder causes rain. But something to keep in mind, what makes this one fairly tricky and what gets a lot of economists is that causal events are correlated. So we could say that a weather front is correlated with a rainstorm, because it would take a rainstorm and a weather front often happen together. So they are correlated, but actually find one is causing the other one. So in the other example, the weather front is causing lightning and thunder, but it's also lightning and thunder happen along the same side of the weather front. So all causal events are correlated, but not all correlated events have a causal effect to them. So this fallacy comes in whenever there is a third event causing these 2 other correlated events to appear as if there's a causal event between them. The next logical fallacy we're going to talk about is the fallacy of composition. Fallacy of composition says what is true of a part is true of the whole. So Adam Smith, one of the founders of modern economics, often considered the founder of modern economics, states that everyone working in their own self-interest is best for the whole. So everyone acting in their own self-interest is often best. That's what Adam Smith said. Well, John Nash, whenever he developed Nash equilibrium, said that needs a little bit of revision. He said that not always is it in the best interest of the whole for everyone to act in their own self-interest. An example of that would be, let's say you go to a football game. It is in your own best interest, instead of sitting down in the bleachers while everybody else is sitting down, for you to stand up. If you stand up, then you have a better view than everybody else. So what is true in a part, which would be you standing up at a football game because it is in your own self-interest, is not true of the whole. Because if everyone at that football game stood up, then what would happen? Well, your view would just get blocked, and there'd be a lot more people with their views blocked than actually helping. So when it says what is true of the part is true of the whole, that does not hold true in something like a football game where one person is standing up. So that I brought up there Nash equilibrium because I wanted to reference the video that is in your PowerPoint of the Chapter 2 notes. That video is taken out of it's a movie called A Beautiful Mind, about the life of John Nash. John Nash created or developed and kind of came up with Nash equilibrium. This is where he more or less proved Adam Smith's theory of everyone working in their own self-interest is best, proved it wrong. And that scene that I put on there, or that video that I put on there, is when he kind of thought it up according to the movie. And in the movie, it was saying that if all of the guys go after one girl, everyone leaves there without a date. But if all of the guys don't get in their way and they all go for the individual ladies and don't go for the best looking girl in the bar, nobody gets in their way, nobody gets in each other's way, and they all go home with the date. So if everyone acted in their own self-interest, they'd all get in each other's way and everybody would leave alone. Whereas if they act in what is best for the whole and everybody does not act in their own self-interest, then everybody wins. So that's why I threw that video in there, because it deals with this fallacy of composition. The next main fallacy I want to talk about is the post hoc fallacy, which means after this, therefore because of this. It's saying that because something happened after, or because there's two items and the second one happens after the first, that means that the first one caused the second one. In your book, they use the example of the rooster is crowing in the morning, so the sun comes up, which says after this, so after the rooster crows, the sun comes up, so therefore the sun only comes up if the rooster crows, which we all know that's not true. It doesn't take a rooster crowing for the sun to come up, but it's because it's after this, therefore because of this, that's where the fallacy comes in, as saying something like the sun's going to come up because the rooster did crow. The last one I want to talk about is the zero-sum game. A zero-sum game is more or less defined as if someone wins, another must lose. You think about it this often in sporting events. For one team to win, the other one must lose. So does that really hold true in economics? No, it really actually never holds true in economics. The reason that they make this assumption is because it says that they are assuming that value, or the value of a product, cannot be created or destroyed. They're assuming that it's kind of like a physics deal, where value cannot be created nor destroyed, which that is not accurate. Through one of the last videos, we talked about marketing and saying that value can be created through changing things of this commodity. So, for this to hold true, it means that value can be neither created nor destroyed. That means that a bushel of corn bought from the producer must equal the same amount as a bushel of corn sold in the store, because value cannot be created, which that does not hold true. So, what it's saying is that instead of it being a win-lose situation in economics, it's generally a win-win situation. Because without coercion, everyone wins or nothing will happen. And what I mean by that is, if you go to make a deal with somebody, if you're going to go buy a car from them, you need to be able, or before you buy the car from this person, you need to be able to say, yes, that car is worth more than what I'm paying. Or it's worth more to me than what I'm paying. And I'm going to be happy about it because it's worth more to me. On the other side, for the seller to sell the car, he needs to be able to say, yes, that car is, or the price that I'm going to receive from this car is enough to make it worthwhile for me to sell the vehicle. So both of them win. A lot of times the car seller gets more money than what he's really hoping for, and the car buyer buys it at a lower price than what he's really thinking it's worth. So the buyer wins because he bought in his mind, a higher value car for less money, and the seller wins because he received as much as he wanted, if not more. So without coercion, without somebody basically holding a gun to your head, you're never going to enter into a deal unless both the buyer and the seller are happy. And for the buyer and the seller to be happy, then it becomes a win-win situation. So the zero-sum game says for someone to win must mean that someone else must lose, is not really accurate in reality, because in reality, for a deal to actually take place, for a transaction to go through, both parties must be happy with it, therefore both parties must win.